is the 5th video of a 6-part series that aims to provide an overview of wastewater operations at meat processing plants and guidance on their day-to-day management. In this video, we will be exploring the capture, storage and combustion of biogas. Biogas is a byproduct of the anaerobic treatment of wastewater from meat processing plants that is either discharged to the atmosphere via vents, encrusted or covered anaerobic ponds, or captured and combusted in a flare, or stored and used as a valuable, clean and renewable fuel source. Safe operating practices manage the risks associated with biogas. To appreciate the importance of knowing and applying these practices, personnel should understand the properties of biogas and how to manage the risks associated with its capture, storage and combustion. Biogas comprises of some carbon dioxide, but is predominantly methane, which usually makes up around 55 to 75% of the gas. It is also saturated with water. Small amounts of nitrogen, oxygen and hydrogen sulfide are also commonly present. Methane comes from the breakdown of organic matter in the wastewater. It is combustible and, when mixed with air at 5 to 15%, it becomes flammable. Uncontrolled emissions in the presence of ignition sources must therefore always be avoided. Biogas is colourless, so there is no visual warning of its presence. However, the hydrogen sulfide in biogas gives it its characteristic rotten egg odour. This is formed from the biological reduction of sulfates and decomposition of organic matter. As well as creating an odour, hydrogen sulfide can also be toxic and corrosive, depending on its concentration. Most measurements of hydrogen sulfide at Australian beef processing plants suggest a relatively low hydrogen sulfide contamination, less than 2,000 ppm, but this is still sufficiently toxic to seriously affect humans who come in contact with it. A single breath of pure biogas would result in immediate collapse with loss of breathing. Asphyxiation by biogas due to the absence of oxygen is a further threat. The potential for leaks or the accumulation of hydrogen sulfide in confined spaces should be kept in mind at all times. Biogas that is water saturated will not produce as much energy per cubic metre. Furthermore, biogas pipelines are prone to condensing large quantities of water which can contain hydrogen sulfide, causing it to be corrosive. For this reason, biogas collected from the cow is dehumidified prior to being used as a fuel source. Methane has a specific density of 0.68 kilograms per cubic metre. As it is lighter than dry air, most biogas leaks will rapidly dissipate upwards into the atmosphere. The burning of the biogas also significantly reduces greenhouse gas emissions by converting the methane component in the gas into carbon dioxide. This reduces the global warming potential of the methane by 21 times. When combusted, carbon emissions are reduced and the odour is destroyed. The use of biogas for boiler fuel is increasing in the Australian red meat industry. Cost savings achieved by using the biogas to substitute natural gas as boiler fuel are significant. Burning methane in a boiler also reduces carbon emissions due to the savings in natural gas that would have otherwise been combusted in boilers. Even greater savings may be possible if the biogas displaces coal rather than gas. The energy from biogas can also be transformed into electricity and heat by cogeneration. Electricity can be used on-site or exported to the electricity grid. Gas engines and microturbines are the most common technology used in cogeneration. Significant carbon emission savings can be achieved by burning biogas and using electricity generated on-site or exported to the grid. Further carbon abatement may be possible if the waste heat from the gas engines is further utilised to generate hot water for the plant. Covered anaerobic lagoons, or what is commonly referred to as CALs, are lagoons covered with a synthetic geomembrane. CALs are able to effectively trap biogas for collection and use. A CAL typically consists of an earth dam with an impermeable liner, a cover which is fixed in place by an anchor trench or a concrete ring beam. Wastewater inlet and outlet pipes are designed to allow the wastewater to enter and leave below the pond surface. A biogas collection ring main around the lagoon perimeter and under the cover is often used to collect the biogas. The ring has single or multiple discharge points through the liner or cover. Biogas release valves are a safety feature to release gas that is unable to exit through the collection ring. This generally happens when preset pressure under the cover is exceeded, for example, if there is a blockage or prolonged flare shutdown. Varieties range from simple pipe spears, more sophisticated water seals, and weighted flaps. The weighting and stormwater removal system work together to minimise stress to the pond cover. The weighting system firstly minimises wind forces on the cover and provides low spots for water accumulation. The stormwater removal system pumps the water away from where it accumulates. Excessive amounts of accumulated stormwater reduce gas storage space and can block pipes or biogas flow under the cover. The cover will also have inspection ports and, in some cases, manholes. Sludge removal systems can also be installed for the periodic removal of accumulated sludge.
All operators should be proficient in the components of the biogas plant and train. From the covered anaerobic lagoon, the gas can either be sent to the flare or to the boiler, or in some cases a cogen plant. The pipeline can either be above ground or below it. The train will always include a knockout pot, which can either be a stainless steel vessel or it can be in the ground. It's essentially just to drain any moisture from the biogas to protect boilers or instrumentation that is further downstream from the cover. The train will include blowers that drive the gas along the pipeline and flow and pressure devices that control the flow of the gas, and is usually controlled by the pressure under the biogas cover.
It is important to shut off the biogas supply if the flare is not functioning or losing flame. This is the job of the fast-acting slam-shut valve. Another important safety device is the flame arrestor that prevents a flame front running back through the biogas supply line. Flares have a priming system where LPG feeds the flare where it needs reigniting. Flares are used to safely incinerate the biogas, reduce carbon emissions and destroy odour. There are two main types of flares, a fully enclosed flare and a candlestick flare. The train may have a number of additional elements to condition the gas. These include a stripping tower to remove or strip the hydrogen sulfide that is corrosive to pipes and motors. This is generally required when biogas is used in boilers or cogeneration plants, and equipment for dehumidification. Water in saturated biogas is undesirable for cogeneration engines and is often chilled so excess moisture can be condensed and removed. When inspecting the system, operators should observe all posted safety signs and protocols and be familiar with the location of safety equipment, such as fire extinguishers and emergency shutdown points. Operators should ensure monitoring instruments such as the biogas flow meter, methane and/or oxygen analyzer and pressure detection devices are operating properly. The high moisture content and corrosive nature of the biogas can cause problems with instrumentation. Where instruments become unserviceable, seek maintenance support quickly. Operators should inspect the biogas delivery lines, especially where they connect to the CAL and major equipment items, and check for leaks regularly. Maintenance should be notified if leaks are found. Note that air leaks into the biogas piping is as much a concern as methane leaks out. Generally, it is recommended that the oxygen content of biogas is less than 4% of the volume.
When I'm doing inspections, I check the blowers are operational, and the flare, I check that it's odourless and colourless. If flare alarms were sounding out constantly for a long period of time, I would seek urgent assistance, because this could indicate that the biogas is rapidly accumulating under the cover. The accumulation of gas under the cover could cause it to inflate to the point where you'll get emergent evacuation of the gas through the cover.
Overinflation in windy places can also expose the CAL cover to high mechanical stresses with the risk of severe damage. It is also important to regularly check that the pilot gas fuel is sufficient for flare operation. While on inspection, operators should check at least weekly to see if there is any unusual blower vibration or temperature variation and notify maintenance if there is. The knockout pot also needs to be drained at least weekly and more often if necessary. While there, operators should look for evidence of unusual drainage water, for example, water containing foam or mousse-like contents. Most monitoring is performed online. This information can be logged to the Plant Supervisory Control and Data Acquisition, or SCADA, system for reporting and monitoring. A log should be maintained by the operator of any unusual aspects of the system. Biogas system failure is associated with significant hazards and sites are often remote. Thus, the primary responsibilities of the supervisor should be to ensure that all safety protocols associated with the CAL and biogas capture system are clearly laid out in work instructions and standard operating procedures. They must ensure operators are competent in following work instructions and that necessary personnel protection and other safety equipment is available. Supervisors must ensure that appropriate investment and maintenance support is provided to the biogas capture system and that regular long-term checks and maintenance are performed according to the manufacturer's instructions. Supervisors should regularly, preferably weekly, check biogas production and methane content. This is the most rapid and reliable means of assessing the health of the cow. Supervisors may also need to liaise and report to appropriate state regulatory authorities regarding the biogas capture system.